Good morning, students. Today we'll do the methods of preparation of alkenes. Already we have started about the methods of preparation. In last class we have done one method by dehydration of alcohol, and this is the second method, number 2 method by or you can write from vicinal dihaloalkanes. Vicinal dihaloalkanes. So this is another method of preparation. From vicinal dihaloalkanes you can prepare the alkene. Now dihaloalkane means those organic compound in which the alkane contain two halogen atom, then it is called dihaloalkane. And there are two types of dihaloalkane. One is called vicinal dihaloalkane and one is called geminal dihaloalkane. For example, this is one of the alkane. Suppose this is the carbon ring. When two halogen are present like this way, suppose two chlorine are present like this way, chlorine is halogen. When two chlorine are joined with adjacent two carbon, then it is called vicinal dihaloalkane. And when, suppose this is the carbon chain, alkane, when both the halogens are joined with only one carbon, then it is called geminal dihaloalkane. So when the alkane contains two halogen, it is called dihaloalkane, and if the halogens are joined with adjacent two carbon, it is called vicinal dihaloalkane, and if both the halogens are joined with a single carbon, then it is called geminal dihaloalkane. So here we will consider the vicinal dihaloalkane, and from this vicinal dihaloalkane you can prepare alkene. So now suppose this is one example of vicinal dihaloalkane. One chlorine is added with this and another chlorine is added with this. So this is one example of vicinal dihaloalkane because because two halogens joined with adjacent two carbon, and the name IUPAC name of this compound will be 1, 2, 3. That's why it is called 1,2-dichloro. 1,2-dichloro. For 3 carbon it is called propane. 1,2-dichloropropane. When this type of the vicinal dihaloalkane is react with zinc metal in presence of one catalyst, your catalyst is methanol, CH3OH, this is called methanol, and some amount of heat is required. Then in presence of zinc, both the chlorine will eliminate from this compound, and this is one example of elimination reaction. And how the chlorine will eliminate it? This carbon chlorine bond will shift from this to this position and it produces double bond, and the chlorine will release as Cl plus. When it goes to double bond, this carbon chlorine bond will break and it will release as Cl minus. Both the chlorine will release from the compound and this single bond will be converted to double bond. You will get a compound like this: CH3, single bond CH, double bond CH2. And these two chlorine atom combined with zinc, they produce side product which is called zinc chloride. So this is your propene, and like this way you can prepare the alkene. If you take another example, this is another example of vicinal dihaloalkane. You can take bromine also. Suppose these two are bromine. Then it is called 1,2-dibromoethane. 2 carbon present, that's why it is called ethane. When you react with zinc in presence of methanol and heat, then both the bromine will release and the bromine will combine with zinc to form zinc bromide, and the product you will get as propene. 2 carbon present, that's why you will get ethene, and the side product you will get as zinc bromide. So this is one of the method by which you can prepare the alkene. Now number 3 method, another method. So first method we have got by doing dehydration of alcohol you can prepare the alkene, and similarly from vicinal dihaloalkane you can prepare the alkene. And this is number 3 method from alkynes, or by hydrogenation of alkynes. By hydrogenation of alkynes. You know hydrogenation means addition of hydrogen. For example, this is one of the alkyne. As you know, alkyne contain carbon-carbon triple bond. So here two carbon present, that's why it is called ethyne. When you add hydrogen with your ethyne, in presence of catalyst nickel is used as catalyst and temperature required 573 Kelvin. Then both the carbon will take one hydrogen. This carbon will join with one hydrogen and this carbon will join with another hydrogen, and the compound goes to CH2 and the triple bond is converted to double bond. This type of reactions are called addition reaction. I mean ethyne is converted to ethene. So by this way also, from alkyne you can prepare the alkene. Another example, this is one of the alkyne which contain 3 carbon, and this alkyne is called propyne. When propyne is added with hydrogen in presence of nickel catalyst, temperature required 573 Kelvin, then both the triple bonded carbon will join with one hydrogen and it will convert it to propene. I mean it goes to like this. Triple bond is converted to double bond. So this type of reactions are called addition reaction. In addition reaction you don't get any side product. So from alkyne also you can prepare the alkene in this way by adding hydrogen, and this type of reactions are called hydrogenation reaction. Hydrogenation means addition of hydrogen. So 3 methods I have given. Now I'll give you the number 4 method. Number 4 method from alkyl halide. Alkyl halide means when halogen is present with alkane, then it is called alkyl halide. For example, this is one of the alkane, general formula of alkane, which contain one halogen like this. This is called alkyl halide, or it is also called haloalkane. When it is react with potassium hydroxide, it should be alcoholic medium. I mean potassium hydroxide you have to dissolve in alcohol, then it is called potassium hydroxide alcoholic. When you dissolve in water, it is called potassium hydroxide aqueous, and when you dissolve in alcohol, it is called potassium hydroxide alcoholic. Then what happens? When you react with KOH, then elimination reaction taking place. This CH2, actually this CH2 is present like this, RCH2, CH2Cl. One of the carbon hydrogen bond will shift from this to this position, and the hydrogen will release as H plus, and it will convert it to double bond, and this bond will break and the chlorine will release from with the bond. I mean chlorine will release as Cl minus by taking the bonded electron, and H will release as H plus ion, and this single bond will be converted to double bond. I mean you will get the product RCH double bond CH2. Here potassium hydroxide is present. The K plus ion of potassium hydroxide, K plus ion combine with Cl minus ion to produce KCl, and this OH minus ion combine with this H plus ion to produce water. So these are the side product, and the main product you will get alkene. For example, if you take this one CH3CH2Cl, which is called chloroethane, 2 carbon present, that's why it is called 1-chloroethane. When you react with potassium hydroxide alcoholic, then elimination takes place. Chlorine will release from this carbon, and from this carbon one hydrogen will release, and in between the carbon you will get the double bond. I mean you will get the product CH2 double bond CH2, you will get ethene. The hydrogen released from this carbon combined with OH to produce water, and the chlorine released from the compound combines with potassium to produce potassium chloride as the side product. So this is another way to prepare the alkene. From haloalkane you can prepare the alkene. You can prepare the alkene from dihaloalkane also. You can prepare the alkene from monohaloalkane also. I mean if the alkane contain 2 halogen, then it is called dihaloalkane, and if the alkane contain 1 halogen, it is called monohaloalkane, which is also called alkyl halide. So these are the methods of preparation of alkene. By applying any method you can prepare the alkenes.